I'm going to talk to you about debugging web applications in a production environment. The reason why I chose this topic is because this is actually a very difficult thing to do, especially because as you know, we're very Perl focused, and the Perl debugger is particularly awful, and our most effective debugging technique is to put print statements in our code. You don't have that option in a production environment. Just out of the question. So I'm going to cover a good mindset to have during a production problem. I'm going to talk about what makes the production environment so difficult, some things about web applications and their nature, and why that nature sort of dictates the tool set that you will use when debugging a production problem, a workflow that you can use when you have production problems, and then I'm going to walk through strace, PS, and GDB, and look at some tools that will help you to use those tools for the tools. Most of the information here comes from problems that we've had at Live Nation in production. Put some stats there. Last time we had a really big production problem was sometime in February, I think it was. And I think you were involved somewhat, Michael?
Which one? Size kills of Apache?
Size kills, yeah. I think it was in February. It was quite a big problem. It lasted for a number of days, and one of the sessions we were there, we did get over about 400 orders a second across all clusters. It was very, very hairy. And I was able to collect about gigabytes of data, log data, strace data, lots of data. Big headache of data. So let's talk a second about the debugging mindset. And for this, we're going to get some help from Mr. Sherlock Holmes. This first quote I love from him is, it's a capital mistake to theorize before one has data. Insensibly, one begins to twist facts to suit theories instead of theories to suit facts. So in this situation, you have a problem in your production environment. It could be slow performance or crashing or something like that. And it's very easy in this situation to think you maybe know what the problem is and to start going in that direction, all the while missing the real problem. Part of this is to do with the nature of the production environment, that it is very complicated, it's fast moving, so it can actually be very difficult to really know what the cause of a problem is, and a misconception can really guide you in the wrong path. The last one is eliminate all other factors, and the one which remains must be the truth. And the basis of this is trust your data. Like, if your data is showing you one thing, you have to trust it. If it's not showing you something, then it's probably not there. But you can use your data to do what he says, to eliminate things that aren't part of your problem and focus on things that are part of it. Excuse me. So, production environments. Production environments remind me of the video game Frogger. Are you familiar with this game? I wasn't sure when I put it in the...
I'm familiar.
Anyone else familiar with Frogger? So, okay, that's good. So, this is you, and you're here, and you have to get here. And the cars and the logs and the turtles are moving. So, basically you have a number of obstacles to your goal, and the obstacles don't stop moving. And you can go backwards and forwards to kind of dodge it, but if you get hit by the truck, well, you're dead. The only thing, I know I'm going away from a topic that I didn't like about this game, is that if you landed in the water, you died, but I thought frogs could swim. But anyway. So in a production environment, your users won't stop. So in your development environment, you can shut down your server, restart it, put in your print and warn statements. This is absolutely not an option in your production environment. The other problem you have is that you can't see what your customers are seeing for the most part. In your development environment, you hit the web page, you see the error output, You experience it. You don't get that in your production environment. You just have to sort of use whatever tools you have to guess what they're seeing in some way. There's also security concerns in your production environment. At Live Nation, you won't have root access in production. You will be given sudo access, so you'll be able to run some commands as root. There's also sensitive information there that means that if you collect some data in your production environment, you might not be able to take it out. And it's fast. It's like the cars. Like I said, 400 orders a second is a lot of data flying by you, and it can be very easy, as I've done, to basically miss the problem. And the amount of data you're going to get is huge. It's 5 minutes.
Go.
So this is a workflow that I find helps when dealing with these production problems, is that in order to sort of help us with the problem that Sherlock Holmes was trying to help us with, is that once you get into your production environment, this should be your primary goal, which is to simply collect as much data as possible. And some of the tools we can use that I'm going to show you towards the end. And in a Live Nation on sale situation, you're going to collect gigabytes of information. It's just huge. Once you've taken this data, your next step is to filter it down to information that's actually relevant to your problem. Once you've filtered it, then you can begin to analyze it. And this step tends to become a cycle between analyzing this set of data and then filtering it some more, analyzing that and filtering and analyze and filter until hopefully eventually you come to the source of the problem. So we'll talk a little about the nature of web applications with a little help from it's a well-known factor, 87.36% of all web applications are I/O bound. Essentially, all your web app does, and this obviously oversimplifies your web app, but it's a lot like, I think, making sausage. You're taking all kinds of things and putting them into one thing that people actually want to digest. Your app opens up a database, it opens template files, reads in data from the user, and it puts out a web page. This is, I know, because our job is very difficult and I'm making it sound very simple, but all of our web apps look like this. So because it's all driven by I/O, in your operating system, there's only one way to do I/O, to read from sockets, to read from files, to put information out of sockets, and that's via system calls. So if you imagine this blue pill is your application, your part of the code only lives on this side. Your application is built on top of libraries. Your libraries make system calls into the kernel, and this is where the magic happens. All of the I/O that happens, actually reading from files, reading from the network, displaying pages, actually really happens here. Your code is just sitting on top of this. So by looking at system calls, you can get an idea of what your application is actually doing in terms of what requests it's receiving, what database calls it's doing, what database results it's getting, and what it's delivering back to the user. The other issue I didn't mention the other day is that in terms of performance, I/O is actually the worst thing that computers do. Computers are terrible at doing I/O. It's slow, it's horrible, but you have no choice. You can't do a web application without I/O, so welcome to the real world. So some common system calls I've actually listed here. Can we stop the video? Common system calls are listed here. Most of them are, these three are mostly self-explanatory. Open opens files, reads from sockets, writes to sockets or file descriptors. This one executes another application. This one you'll see a lot. It's to do with resizing memory spaces. This is what the C library function malloc uses amongst other functions to actually get more memory back from the operating system. Time, you can guess what time does. Mmap maps files into memory addresses. I/O control is how your application sometimes makes I/O requests or operations against a device that don't make sense in the sort of reading, writing. You know, an example this would be if you are reading or writing from a CD-ROM drive, there's probably an I/O control that tells it to eject the disk. So it's sort of operations to do with a specific device, and connect is to do with opening sockets. All the system calls are described in the man pages, usually in section 2 on a notes box. You'll actually find that these are the C library wrappers around the system calls, but they're documentation from C, correct? And that means. And the system calls are based around C functions, so they're always going to take in some number of arguments and return a singular value. The convention with system calls is that a negative value is usually an error code, and those error codes are defined very well, and they all tend to follow a certain pattern. So the first tool we're going to look at is, are we good on time? That was a good stop. First tool we're going to look at is strace. So strace allows you to see what system calls an application is actually using, and it also allows you to take a look into what arguments it's getting and what value it's returning to your applications. There's two ways of running it. Is that you can tell strace to run the application for you and it will log the output. And the other is that you can connect to an application that's already running, like Apache, and see what it's doing. I said here it needs root access. I was corrected on this. It actually requires root access if you're connecting to a process that belongs to another user. And the Live Nation says this is usually what you'll be doing. If you log in as TMWeb, the browser might be, the process might be running as a different user, and also the Apache parent process runs as root. So you will need to become root in order to strace Apache. You'll be able to find strace in your distribution package manager. It's also installed by default on all of our it also generates a ton of data, about 116 lines of output for a simple ls in my home directory. And it only really becomes useful, like in our workflow, after you actually really filter this information, because a lot of what an application does is sort of boilerplate. It's not really useful for some problems. So we'll go ahead and take a look. Is this readable? Should I make it bigger?